He's gonna be my new consultant.
Speaking of paper trail.
So may I collect your proofs, my friends? Please. Thank you. And I'll have all this stuff back to you on Monday when Monday
Oh, yeah.
when we get back.
Or then we started it on Monday.
Oh, I think about that.
But, yeah.
Thank you.
I saw it on.
And make sure you got a copy, right? You got a copy?
Wait, do I?
You got a copy? Okay, that works. That's a copy. Digital copy. And then Cadence will be popping back in.
Yeah.
All right. Went to a haunted house last night.
Ooh, which one?
Frightmare.
Okay.
Anybody been to Frightmare in Westminster?
No.
I think my aunt went there.
Out of
Really?
10, how
Is
scary.
was there free wine tasting?
No.
Oh,
No.
just kidding.
Not that I was invited to anyway.
Damn,
Yeah.
I want to go to some wine
I
tasting.
highly recommend going to a haunted house. It's good stuff.
How much was it though?
It was too much, but
Money?
it was like $40 a
Too much.
ticket.
Oh!
Where?
Frightmare? It's literally down the street from me in Westminster. So, can I grab your?
Wait,
Thank
so
you.
I'll walk down the street too.
Trick or treat.
We drove.
It's gonna be in the
drove.
basement.
We were
He's
sober.
hiding in the basement.
Yeah.
Ish.
So, yeah, I wouldn't drive drunk. I definitely would. I don't even drink really.
Well, yeah,
so.
looks like it.
I don't think
If
it
this
is.
man can, I mean, that's equation.
What's that? Oh, my proof.
Thanks,
Alex.
Yeah.
You got something for me, Joe?
Yeah, I think this is it. Oh shit.
It's a disturbing
Probably write my name on it.
uncertainty. Here's something with stuff written on it. This might be my proof.
Yeah, well,
Thank
yeah,
you, sir.
there you go. Give you all the things outside too.
Cool. So, starting some new stuff. This will be the last stuff before the next exam. I'm kind of thinking our next exam will be like a week from next Monday. So, like when we come back on Wednesday, we'll talk all about it. I'm not going to brutalize you. There's not going to be proofs on it. It's going to be basic knowledge, and maybe even over this like next period of time, next few days, I'll get you information about what that might be. But I do have an assignment for you, so maybe I won't do that. I'd rather you focus on a new web work, which is up, and it is titled Sequences. And yeah, now that I think of it, we probably wouldn't have an exam a week from Monday. It would be a week from next Wednesday, probably. 2 weeks from today. Sequences, and this is due next Wednesday at the end of the day.
Next Wednesday.
So we're totally gonna start on this ahead of time, right, everybody?
Why is it so long?
We're gonna start on this super early, yeah, and we can talk about it on Wednesday when we get back. I mean, Monday, when we get back. That's some pretty bad winking. But this is fun and less conceptually difficult than a lot of things can be in this class, certainly proofs.
So let's do the second.
Yeah, that sounds right, yes. Yeah, thank you, Cadence. It's a nice summary of it, nice precise summary. So, a sequence is a list of numbers. That's pretty easy. That's one definition. That's like the most accessible definition. It is by far the easiest definition. We will not go into the others. This gets everything we need in it. So a list of numbers separated by commas, essentially. A sequence can be infinite or finite. So it can be finite, in other words, it ends, or infinite, in which case it does not end and goes on forever. Let's talk about some examples. Today's a lot of examples in pattern finding, which I'm assuming you like pattern finding. You're a CS person. It's kind of like your job is to find patterns and exploit them and optimize them. That's like one of the key roles of your position. as a computer scientist, your life choice as a computer scientist. So in general, we write a sequence in the form. So when I say in general, I mean like if I don't know what the sequence is and I'm trying to describe to someone what I have a first term, and I would say a sub 1, a sub 2, a sub 3, and if I actually have an end to that, that's a finite sequence. And there are, each one of these things is called a term in the sequence. So these are the terms. This is the index of the sequence. And if it's an infinite sequence, it would look something more like this. And Daniela is soon to have all sorts of fun with these in Calc 2. I can feel your excitement. I don't even have to look. So if I put ... some ellipses, that indicates this pattern continues on forever, never ends. So I just make a little note here, never ends. Which is the cool kind, yes.
What does it mean if a sequence is bounded?
Ah, cool. We'll get to that. Yeah. Let me make a little note here. So let's make sure to talk about bounded sequence. Let me give a couple examples first, and I think that'll actually help to understand the whole thing.
Okay.
So, Yvonne, I asked an awesome question. We're going to get there in a slightly roundabout way. Let's talk about some examples. And actually, I'm going to put these examples over here because we're going to refer back to them a couple of times today. So first example, 1, 1/2, 1/4, 1/8. What do you think comes next?
1/16.
1/16. How did you get that? What do you see as the rhythm here, Cadence?
Keeps cutting in half the common ratio.
Oh, look at that. There's a person who maybe studied some geometric sequences at some point. Maybe not.
It was in the prep.
Oh, was it in the prep? Oh, cool. Whoever signed that was on the ball. Awesome. So notice there's a common ratio here. The key thing is trying to see if there's a pattern. There's not always a pattern, but here the pattern is somewhat evident. Notice that all the terms here, so let's get to Yvonne's question. All the terms here are between 0 and 1. So if I call this a sub 1, this is a sub 2, a sub 3, on up, I could make this little note that the absolute value of a sub I, and this I is going to be general, is less than or equal to 1. It's pretty obvious this is the biggest thing in the whole thing, right? So 1, and then everything gets smaller after that. So this is for I equals 1, 2, on. The sequence is bounded because there's a number that bounds the magnitude of all the elements in the sequence. Let's take a look at another one. How about this one? We've got 1, 2, 4, 8, 16. Really, the reciprocal of those. What's next? 32, 64. These are great numbers for computer scientists, right? These are like the binary places. This is what computers run on. So we've got nice powers of 2 coming up here. So I could notice here that this is 2 to the 0. This is 2 to the first. 2 squared, 2 cubed. If I call this A1, A2, A3, A4, then I could even come up with a formula here. And Yvonne, this one's going to actually, I think, get right to the point of your question. We can write an expression for computing the ith term of the sequence. And now I kind of want your help here. So a sub I, can you help me come up with a formula for this in terms of I? I want a little formula here so that if I asked you, hey, what's A33?
It would be 2 to the ith, right?
2 to the ith. Okay, let's check it out. So if I do the indexing from 1, starting at 1, is this gonna check out? Because then a sub 1, I replace the I with a 1, would be 2. So it's close, Cadence, but it's a little
-1?
I minus 1. So check this out, friends, and let me know if this needs some explanation. Here we have a nice formula to find the general term. Yes?
Do sequences always start with like variable sub 1?
No, they do not, sir.
Okay.
Yeah,
It's just in
absolutely.
this-
Just for the sake of this, I kind of wanted the rhythm to be off. So I could, and what an awesome question. I could actually just say, this is A0, A1, A2, and have a nice paired, I literally wanted to use the word cadence here. So I feel like you're gonna be all over finding these patterns given your namesake. So let me know if there's any questions about what I've said so far. So we're gonna take this further. Okay, Yvonne, this sequence here, there's no number that is above all of those. So you say, well, certainly the a sub I terms, their magnitude has to be less than or equal to something. But no matter what you put here, even if it's a Google, I can eventually find an I that surpasses that bound. We can graph these sequences, and I think this will also really help. We can graph a sequence, and I often do this when I want to understand something about their nature. So this is your index I on this axis, and we have it 1, 2, 3, 4, on up. So if I was going to plot this sequence, I would have a sub 1 is 1. So this is actually 1 right here. That's a little shitty. A sub 1 equals 1. That's a little less shitty. So we got that. A sub 2 is 2. So it's twice as high. So that's a sub 2. A sub 3 is twice that. So I'm going to run out of space here real quick. But if that's 4, that's a sub 3. And I'm going to put a dot right there, right above 3. And so another way to think about bounded, Yvonne, is can I find a little line above and a line below where the sequence lives forever? So a bounded sequence lives in some strip that I can draw that is a finite height and a finite lower part.
Yeah.
This sequence is not bounded because no matter what you make that strip, eventually it will head out of it. Let me actually give you an official definition here. So we can say a sequence is bounded. I'm not going to erase the love. I'm not responsible for that. I can't do it. They got me. So let's make a nice definition. A sequence, and I'm going to introduce some notation here too. We can put it in parentheses. A sub I. So this little parentheses here indicates that I have a sequence. Sometimes you can also write it like this, with these braces. That's supposed to be a brace. Like that. And on the outside of these, I would put the range. So this is I equals 1 to infinity. You don't have to write that, so let's make a little note. Can write the index range. But don't have to if it's apparent. But don't have to if it is apparent. Like whoever's reading this knows already what you expect the range to be, or maybe it doesn't even matter where it starts. So these two are the same ways of writing just this list here, A1, A2, and on up. So a sequence of this form is bounded if there is, so here I got there exists some m that is a positive number so that the magnitude of all the a sub i's is less than or equal to m. Kind of saying the stuff I've been saying, but in a very formalized way. Sorry, get out of your way. And what that means is that this a sub I lives between, when you put absolute value on here, that just means it's between negative m and positive m. So if this is m here, and this is negative m down here, the sequence lives in here. It lives in a strip. So that would be bounded. Does that help kind of get an intuitive sense?
Yeah.
So essentially, if I know the sequence grows unboundedly, like it flies off to infinity eventually, plus or minus infinity, that is an unbounded sequence.
So if you wrote it in integral notation, it'd be just like your lowest and your highest.
Yeah, exactly. So like right here, so I could say it lives in this range. That would be a great way to do it. Saying this cadence though doesn't give me a whole lot of information because that's just saying, oh, it's some real numbers.
Would that be unbounded, or is that still bounded within real numbers?
That is bounded within real numbers. Yes. Yes. We'll take a look at some more examples here to really give this. This is like one of my favorite topics, for sure. Let's take a look at a few more examples and then get some formula. We're going to do a lot of work trying to find patterns and assigning formulas to the patterns. Let's see, what else do I got here? Here's one. So more examples. 1, minus 1, 1, minus 1, 1, minus 1, forevermore. That is a sequence of values that continues on and on, so we have an infinite sequence. Is it bounded? Yeah, it is. Can somebody give me a bound on it? Like, what's an upper bound? A thing that it's never above? 1. What's a thing it's never below? -1. Beautiful. So here we have an infinite sequence. It is bounded, and that I could say here even more particularly, it lives in the range -1 to 1. Never comes out of that, if this is the truth. And if you're giving this to someone, you're basically telling the truth is it never changes this rhythm. What's a nice way to write this? Let's use a sub n. I like n's, it's better. So if this is n equals 1, if this is n equals 2, in other words, that's a sub 1, that's a sub 2, that's a sub 3. What's a nice formula for a sub n? Now we got fun. What do you think we could do?
You would use a power for sure.
Definitely need a power, I agree, absolutely.
-1 to n.
Sounds pretty good, let's try it, good start. So -1 to the n, does that sync up? So like what would a sub 1 be?
Oh, and
Would be
+1?
And +1, perfect. So you had to get the parity right on it. You need to make it sync up. And then we would say here for n equals 1, 2, on up, beautiful. Take a look at that and make sure you're following along. Okay, if there's no questions, let's keep going. What about this sequence? 1 minus a half, 1/4 minus an eighth. So now we've got one of our earlier sequences. That's A1, that's A2. Can you just take a minute and write a general formula for it? So A sub n equals. Try it. Give it a shot. Write a formula so that whoever you hand this to could figure out what the 101st term looked like. There's two things going on, right? There's two things moving. The sign, S-I-G-N, the plus minus, and then also the denominator. Anybody got a formula for me? We'll try.
What?
What you got? Oh, no, okay.
Would it be like n divided by -2?
So let's try it. So you're saying n over -2 like that?
Yeah.
So what's a sub 1? When n equals 1, I get -1/2. When n equals 2, so that's this one here. But that's okay, sometimes you can adjust that. When n equals 2, what do I get?
-1.
I get -1.
Um,
And what's actually happening as n gets bigger here, the magnitude is getting bigger, right? So like when n is 100, I've got -500. That's not quite what this is doing here, but I appreciate, yeah.
Is n equal to what step you're on?
N is the step, yeah. Great way to think of that, Alex. N is the
Yeah, I was
step.
looking at it differently.
Yeah, so now you're like, take that back.
Yeah.
I'll take that back, I will.
1 to the n plus 1.
1 to the n plus 1?
-1.
-1 to the n plus 1, love it.
Over 2 to the n minus 1.
Let's give it a shot. That's a hell of a good guess. So check out and I think Yvonne's thought process here was, first off, without the sign part, the plus minus, it's like 1 over 2 to a power that's getting bigger and bigger, right? So this sequence right here, for n equals 1 on up, would look like this: 1/2, 1/4, 1/8. And then Yvonne says, well, wait a minute, my sequence is actually starting at 0, right? Like 2 to the 0. So he subtracted a 1 off of here. And I'm putting words in your mouth, but I imagine it's something like
Yeah,
this.
sure.
Yeah, so first off, this sequence right here, if we have that, that's bad, I don't want to put equals. But this formula would give me this rhythm. Is everybody seeing that? And then we've got alternation of sign. Whenever you have alternation of sign, -1 to a power is your friend, and your fan, and your lover, if you really like math that much. So when you put a -1 to a power on, you're going to get alternation. You just got to adjust this. It's either going to be n or n plus 1. So checking out what we got, then you try your formula. We got -1 to the 1 plus 1 over 2 to the 0. Is that working? So -1 squared.
Yes.
Yeah, that's 1 over 1. It's working. And then the next one, a sub 2, is going to be -1 to the 3rd power over 2 to the 1st. What's -1 cubed?
-1.
-1. So good job. We got our formula. Then the next one's going to be +1 over 2 squared, +1/4. We got a beautiful formula here. So this is really lovely. Good job, Yvonne. Thank you. Is that sequence bounded?
Yes. No.
Yes.
Yes, it is. You were right the first time. Your intuition. What is it? Give me an upper bound.
Upper bound would be 1 inclusive.
1 inclusive. So yeah. So this thing, if I plotted this sequence out, let's actually make a little graph, a little plot of it. So this is the n value. 1, 2, 3, 4. That's pretty bad. Spacing. That's a little better. So when n equals 1, we've got 1. When n equals 2, so this is 1, this is -1, I got -1/2, then +1/4, then -1/8. So notice how it's dying out in some way, but alternating at the same time. And it lives in this strip. Since it lives in some strip, a horizontal strip, it's bounded.
What is the lower bound? Be -1/2.
That is the best lower bound. Yeah, so check it out. So it lives in, I like where you guys are going with this, lives in the strip -1/2 to 1. That's the tightest estimate. You could also say, yeah, it's bounded by -10 and 10. It also lives in there. That still means bounded. It doesn't matter as long as it's a fixed strip that you live inside. So beautiful, beautiful stuff. Any questions, friends, on this stuff? Good, all right. Got some new sequences for us to figure out some patterns for. I had fun coming up with these. I'm sorry, love. Thank you for your presence. Kisses blown. Get the fuck out. There we go. And so here I got it. First thing is, what are the next 3 terms? So find the next 3 terms. And then we'll come up with a formula if we can. So for this one, we're gonna have 1, 3, 5, 7, 9, 11. Take a minute, just think about it. And actually, let's put a couple up here. So we got some problems to think about. 1, or 2, 3, 5, 7, 11, 13, 13, 17, 19. This one's, you got enough for that one, I'm saying. This one needs more, maybe put another one in there. And then let me put one more up here.
Math don't add up.
What's that? What's that, Joey?
It doesn't add up.
Yeah. Yes. Let's just stick with these 2 for a minute. Take a moment and just ponder. The first one you might be able to see right away.
Too much to create a formula,
Yeah, and if you want, if you think you know what the top one is, or the second one, come up with a formula. If you come up with a formula for the second one, I'm taking you on the road and we're gonna be rich.
Oh man, I
I
like
wish
rich.
I could do it with programming, but I don't know if I could do it with formula.
You might, you could definitely do it with a semi-sophisticated program. Yeah, and then come up with a formula for that top one. It's my eraser. Oh, it's right there. So your web work assignment is a lot of this kind of stuff. I just want to make sure we cover everything. Gonna need. What's that?
I said, Yvonne, come on, I'm here to get rich. I'm here for a degree.
Yeah, you don't need you don't need the app.
Yeah.
If you come up with a formula
Just
for
figure
that.
that out. We're
Yeah.
chilling.
Easy. This is cool. You're secretly at math club right now. This is like some math club shit. So boom, I got you. You went to math club. You didn't know it.
Yeah. I'd go to math club.
Would you?
Yeah, if there's free food.
There is always free
Oh
food.
wait, what?
There's always
Wait, when is the next math club, man?
Next Monday, I think.
What time?
I'll let you know. I'll send out an
On
email.
Halloween? Is it gonna be a spooky
Oh,
math
actually,
club?
they might not be doing it on Halloween,
Oh,
but I'll let you know.
spooky math club. He said.
Spooky math club. You know what? Nobody wants to go to math club on Halloween.
I would.
I'm not going to math club on
Yvonne and I would
We're
definitely.
not. I'm not even.
I
Gonna,
would.
You're gonna be in your basement?
here on Monday.
Oh, what? Who said that?
Fine, back up. Can somebody help me out? What's this? What are these numbers?
N plus 2.
And sub 1 equals 1.
Yeah.
The rest is
I'm hearing a lot of things. I'm not sure I agree with any of them so far. What's the next number?
13.
13 and then
15.
Yeah.
17.
17.
19.
It's the odd positive integers, right? So the next 3 are going to be 13, 15, 17. Give me a formula. So if this is n equals 1 and this is n equals 2, what's a formula for a sub n? I heard. What's that?
Equals n minus 1 plus 2. Or like a sub n minus one plus the value of two.
So you're defining it in terms, oh, let's not go there yet. I like that. So did you hear what Cadence is doing? So Cadence is saying, say it again, please.
A of n equals a n minus one plus the value of two.
So how do I know where to start with yours? This is great. Like they increment by 2, right? So it goes up by 2 each one. So he's saying the next one equals the previous one plus 2. I love it. But where do I start, Cadence? Like for example, what's A1 here? Because there's no A0. So what do we need to do?
Did you leave out the 9 between 7 and 11 on the bottom one? No?
I did, on purpose.
Okay, because I was saying, I'd see the 9 up top, but now I'm just confused as well.
Yeah. Well, this is a different one, so don't worry, but this one's, let's focus up here. What is A sub 1? 1. So this is what's called a recursive definition, and you probably saw some of that in your prep for today, right?
Yeah.
This is a recursive definition of a sequence. I love it, really nice. And a recursive definition means that future values are based on current values, are based on current or past values, maybe both. In computer science, recursion's used when you have like a routine that calls itself, right? Has anybody had to solve the Towers of Hanoi problem yet?
Yes, it's so annoying.
Oh, it's so fucking annoying. Yeah, absolutely, it's brutal. But that's a recursive algorithm to solve that. So check this out. This is the initializer. So this is the initial value. And it primes this whole setup here. So if A1 equals 1, then A2 is equal to A1 plus 2 gets me 1 plus 2 is 3. Do you see how future values are going to feed off the current ones? And then let's actually do a few more here. A sub 3, when n equals 3, this is equal to A sub 2 plus 2. So I look at this value. What was A sub 2? It was 3 plus 2 is 5.
I guess, yeah.
What happens if I set A sub 1 equal to 1?
Isn't it set to 1 already?
Oh, 2. Yeah, thanks. Thanks, Cadence. What I meant is 2.
5.
2, 4, 6, 8.
2, 4, 6, 8. What'd you say, Joey? What'd you say, 5?
That's 4. I meant 4.
So, and there's more than just one thing, right? So, like, yeah. So if A sub 1 equals 2, then we get the even numbers using Cadence's recursive formula, because then A sub 2 is A sub 1 plus 2, so 2 plus 2 is 4, and then the rhythm just keeps on rolling across the even numbers. What if A sub 1 is a half? It don't have to be integers. What if A sub 1's a half? What do I get? So what's A sub 2? 2.5. That's how it rolls, Alex. Yeah, add 2 to it. So I would say let's go 5 halves, because that's,
Oh, that's numbers.
yeah, that's numbers.
Yeah.
But there's your
I like
5,
that.
Joey.
Yeah, 5.
Yeah.
That's right the whole time.
So then what's A sub 3?
9 halves?
9 halves.
Is it, yep, 9 halves. What's A sub 4?
13 halves.
13 halves.
13 halves.
Which
Beautiful. Notice how you're just incrementing the top by 4 each time.
Yeah.
Yeah.
Because it's 2.
Let's write a formula that's not recursive for this relationship. With recursive stuff, everything depends on that initial value. So let's set up a formula that's a little more explicit. And what I mean by explicit is I can just plug in n. See, this would make it really hard here. If I said to you, what's A1001? You'd be like, oh God, now I have to write a piece of code, right? Unless you're really into adding half and 2's 1,000 times. So this is not easy to work with. I'll come back to this sequence in a second. Can we come up with just an explicit formula? So I love that we already talked about recursive stuff because I was gonna hold off on that. So a sub n equals, help me out.
1 plus n times 2.
So 1, yeah, how about that? So where are we starting? So if n equals 1, what's a sub 1 now?
So it'd be n minus 1.
We could do it that way. So let's check it out. Let's talk this through so everybody follows. So a sub 1 using this formula would be what? 3. 1 plus 2, 3. And then a sub 2 would be, put in the 2, we have 5. So that's not quite what we want. We want to start at 1. So Cadence's next suggestion, so let's do this, scratch that off. So we're gonna try to spell try. A sub n equals, what was your next thing, Cadence? You said subtract 1 from the n?
Yeah.
Yeah, so check this out. This will work, and it just kicks us back 1 n value. So now here, when n equals 1, we've got a sub 1 equals 1 plus what? 0 equals 1. A sub 2 equals 1 plus
1.
yeah, 2 times 2 minus 1. 1 plus 2 times 1. And were you looking at that part there, Joey?
I don't know. There's a lot of numbers going on right now.
I know, I'm trying to save you, bud. You say yeah. Just say
Yes.
Yes, good answer. Yeah, so then a sub 2 is 3, and now we've got it. We could actually simplify this formula. This is beautiful. It works. All that matters is it works. But I could do a little simplification. This is 1 plus 2 to the n minus 2. I could distribute. And so here's the same formula written in a slightly simpler form, 2n minus 1. That gets me the same thing. When n equals 1, I got 2 minus 1. When n equals 2, I got 4 minus 1. That gets me my sequence. Stop there. Questions on that? Because now we gotta go to the other one that was upsetting Vincent. Does this make sense to you though, Vincent, this one?
Yes.
Awesome, beautiful. So let's go to that next one. That's 2, 3, 5. It's starting to look like the same rhythm. Oh geez, we got that. And then I skipped 8, 9, 10.
Went to 11.
And went to 11, then 13, next dot, okay, sweet. But then I didn't write 15.
Like 17.
I went to 17. What am I doing? What are those numbers?
For the last 4, is it 5 plus 6, you get 11, 7 plus 6, 13, 11 plus 6, 17?
Oh, that's kind of neat. So what do you think the next number is?
19.
19 is the next number. But let me tell you what the next number is then.
Okay.
The next number is 23.
Oh, wait, 17 plus 6 then.
17 plus 6. So you're just adding 6 each time?
Oh.
To the,
Oh,
yeah.
wow.
But it
That's
doesn't work.
working pretty good. Let's keep going. Let's keep going because
That works.
I know what my pattern, that does work so far. That's pretty good. The next number, so for me, the next number is 29. So yeah, we're good.
Wait,
What's
20. It would be like 19 plus 6 though.
It would if yours was right.
Okay.
yeah, exactly. And so I love that. I love that. And here's the cool thing. Given what I had up here, no one could say Alex was wrong. It worked. Well, it almost worked.
Yeah, for the first ones I was kind of, like, I'm wondering if it's like plus something for the first one and
Yeah.
then switches.
Yeah.
Might
So
be overly complicated.
that's really cool. So like if you start, like you think there's a pattern but it doesn't apply everywhere, probably your pattern is a little bit off. Let me keep going. 31.
We're adding by like 2s, 4s, and 6s.
Yeah, we're doing all sorts of weird shit, aren't we? I will tell you, there's no formula.
So
These are the prime numbers.
Oh.
No. Everybody's so disappointed.
No.
No.
That's so boring.
How is
No,
so
what?
I want a pattern.
Prime numbers.
Oh,
So what's interesting about the prime numbers is there is no pattern. Well, there's no formula. So these are the primes. And to find the next one, you just have to find the next number that's not divisible. So you could write a little algorithm. And in fact, I'm doing the algorithm in my head. I check 38. Is it divisible by anything less than itself? Yeah, divisible by 2. Not in here. 39, is that a prime? No. 40. Oh, hell no, right? 41. Yeah, it is. So 41. So the prime numbers, one of the amazing things about this is there is no known formula. No one can say there isn't a formula, but there's no known formula. You will also be using prime numbers like crazy if you ever do cryptography. If you are involved in internet security at all, the prime numbers are absolutely key, literally and figuratively, to working with cryptography. Because there is no pattern. Now there's neat distributional patterns. If you plot them out, we can gain some sense about how spread out they are as we move out, but no one has a formula. So that's what I was gonna say, Joey, if you have a formula for this, we've just solved one of the great problems of mankind's study of mathematics. Right now, we got nothing. All right, so that was upsetting to a lot of folks, so sorry about that. Here's one that might be less upsetting. And this is also a famous sequence. So here's another famous sequence. 1, 1, 2, 3, 5. There is a pattern here, so I won't like yank you around. Again, 13, 21, 40, 34. Was that?
sorry, just jumped.
Oh, you did jump. What's that?
55.
How'd you get that?
You take n minus, or I guess n minus a of n equals a of n minus 1 plus a of n minus 2.
Damn. Once again, living to your name. Unbelievable. You must have like come out and just started like catching rhythms all over the place, and they're like, cadence. This kid's got cadence. So
I got $10. You can do my homework.
that's a really low ball offer.
It's only one assignment. It's not like it's $200 for the semester.
That's also a pretty fucking low ball offer.
Yeah.
I'd say $100 an
So
assignment.
you can tell
people who get paid
I'm
$200
unexperienced at
for
paying for getting my homework done.
There you go, that's good to know. So check out this pattern here. Each next number is the sum of the previous two. So this is 1 plus 1. This is 1 plus 2. This is 2 plus 3. 3 plus 5. And that's what Cadence caught, that there's this rhythm, a recursive rhythm, where the next one is based, what were you gonna say?
Fibonacci, right?
Yeah, that's it. Hell yes. These are the Fibonacci numbers. This is the Fibonacci sequence.
Oh,
Fibonacci
yeah.
sequence.
We just, well, some of us aren't dumb, but
There's 2 C's in that because it's Italian sequence. So this is like one of the most famous sequences around. There's all sorts of kind of bullshitty pseudoscience that claims, you look at
Everywhere in nature.
it's in all over nature. Yeah, like the number of petals on every flower is one of these numbers, and there's reason to think why that might be true. When Fibonacci created the sequence, he was actually studying rabbit populations and how they multiply. So I don't want to get into that whole story, but it came from studying the growth of a population. So let's write out the formula. I think Cadence already laid it out for us, but we can say an plus 2, I'll show you a couple ways to do this, equals an plus 1 plus a sub n. So this is saying current term plus next term, or this term plus the next term equals 2 terms out. Another way to say it, and here we actually have to initialize 2 values. So we need 2 initial values. So here we've got, let's say a sub 1 equals 1 and a sub 2 equals 1, and then that kicks the whole thing off. If you change those initial values, you get what's called a generalized Fibonacci sequence. You get a new thing that kind of has this rhythm, but it's not these same values. We could also do, and I think this is what Cadence was doing, or a sub n equals a sub n, what did you say, Cadence?
N minus 2 plus n minus 1.
Yeah, beautiful. So check this out. It's the same rhythm. 2 terms up is the sum of the previous 2 terms. And then here we'd have to do something like, we can't start at a sub 1 unless we want a negative index here. So we'd probably say, geez, let's see. Well, if we make that a sub 2, how's this gonna work? This might work. Let's try it. Let's just see really quick. And then a sub. No, that won't work because we don't want to let n equal 1. I don't want to let n equal 1.
Couldn't you do a of n equals 2?
Yeah. Or a sub 2. Wait, say that again.
A sub 2 would equal 2.
Yeah. Well, let's see. So I think, yeah, that
Or 1.
would. A sub 3
A sub
then
3
would
equals-
be a sub 1 plus a sub. Yeah, that'll work. Yeah, that does work. That works okay. You just have to start with n equals 3 for this. So this is for n equals 3, 4, 5, on up. So that's a pretty cool sequence. All over the place in popular media and all that kind of stuff. Let me show you something that you might not know about the Fibonacci sequence. If I take the Fibonacci numbers, so this is the first Fibonacci, this is the second, this is the third, this is the fourth. If I start looking at ratios of them, so in other words, F2 over F1, F3 over F2, let me write that out as just numbers. So 1 over 1, 2 over 1, 3 over 2, 5 over 3, 8 over 5, 13 over 8. Check out that sequence. What's the next number? 21 over 13. Does everybody see
Yes.
that? Do you see that? 21 over 13? Then what's one, oh, whoa. What's the next one? Just somebody else besides Cadence. Let me.
34 over 21.
Yeah, 34 over what?
21.
Beautiful, beautiful. Absolutely. So if you were to do, get a calculator out and compute these numbers, what you would see is that this ratio is settling down on a number. And it is settling down on, so this approaches, this is a very calculus-y kind of thing to say, the golden ratio. Have you heard of that?
Yeah.
Yeah.
No.
You have not heard of the golden ratio?
I was laughing because of Always Sunny. I heard the Golden God.
The golden god?
Have you ever seen Always Sunny in Philadelphia?
No.
That's a good thing.
Okay, I've heard a lot of good things about it.
No.
What is the golden ratio?
Spiral. Or
Yeah, that's part of it, yeah.
Yeah.
So, the golden ratio is about like, it's called phi. And it's a number like pi, it shows up all over the place. And it's approximately 1.618, and it just kind of keeps on going. And it is what is considered one of the most beautiful ratios in art. So the Greeks were really into this. The golden ratio appears in a lot of their buildings and sculptures. They tried to implement it in everything they did. And really what it was is if you take the width of something divided by the height of that, so W over H, if that is equal to this golden ratio, that's supposed to be the most appealing rectangle to the human eye.
Really?
And I think they did some studies. Yeah, I think there were some like I don't know how scientific they were, but there were studies done where they had people pick what's the most attractive rectangle in this bunch of rectangles. And apparently people more often than not went with the golden ratio. That may or may not be bullshit. I don't know the veracity of that claim. So Cadence mentioned something about a spiral. Let's talk about that. The golden spiral is built off the Fibonacci number. So you take a square of side length 1. So this is 1 and 1. And then you attach that a square of side length 1. So each of these squares has side length 1. Imagine they're squares, okay? What's the side length of this long edge? 2. So let's put a square there of side 2. So this is a 2 by 2. What's this side length here? 3. So there's a square of side length 3.
Whoa.
So 2, 1, 1, 2. What's the side length up here?
5.
5.
Okay, I see where this is going.
Do you see where this is? Yeah, that's good. And then 8 over here.
Oh man.
That's actually pretty fucking good.
Yeah, you're,
I mean,
I'm impressed.
I'm just like, yeah, I'll take the pass, thank you. He drew a square.
Rectangle.
That's 8
Lot
by
of
8.
squares.
Well, that's a square, yes. So if you keep doing this, and then we got a 13 down here, right? So you can build the Fibonacci sequence in these squares in this way. If you take just the corners of these squares and you go like this, yeah, I guess that's it.
Big
Yeah.
spiral.
You get a thing called the golden spiral. And I don't know shit about the golden spiral, but I think it appears in like shells. That's so the legend goes, in conchoids and stuff like that. Conch shells? Yeah. I just know the math word for it, conchoids.
So I think that's a fact, that's proven. They have
What's
that curve in their shell.
Yeah.
That's a fact. Kind of?
Fact.
Okay. Like as fact as it'll be.
As fact as a lot of things are.
Yeah.
Correlation,
okay.
causation, who's deciding?
Yeah, exactly. So there's more than I thought I'd tell about the Fibonacci sequence, but it's the root of a lot of beautiful things. That is a very attractive spiral. Alrighty, friends. Here's a challenge for you. So challenge 1, give me the next 3 terms. Challenge 2, give me a formula for this the general term. So we're going to go 1, 2, 4, 7, 11. So first job of yours is find the next 2 terms. And actually, I'm going to leave this one as a bonus problem. Let's just find the next 3 terms. So bonus for next Monday would be, give me a formula for a sub n, if this is a sub 1. So if you're missing points in this class, this might be worth putting some effort into. Well, I got some serious writing going on. Huh. You got it?
No.
Oh, okay. It said your pen went down like a man who knew some sequences.
I set it up, and then I'm like, throw it down.
Okay, got it. Now you think.
How am I-
Now you think. All right, I'm gonna run to the restroom. I don't think anybody will be done in the next second or so. I'll be right back.
teeny bet. It's like, you doing proofs in here?
Yeah, I got him out on the mirror. Got you scribe. He won't, so it's just.
He's like, can I get one? I don't know. Oh, man. Left.
I
Ooh.
have a question on
Oh,
this.
question that Tristan's maybe got a formula for.
Oh, I have a formula. I have a question.
Oh,
about
okay, then go for it. Go for it. What's your first
Um,
good question?
Well, I have the formula, but I don't think it works for the very first one.
Same.
All right, do you guys have the same formula? Have you talked?
Did you? I didn't.
Oh, mine's a little different.
I think I've got it.
Let's see what these guys got here first, and then we'll, yeah, it'll be.
I think they're the same thing.
What you got? So let's.
Oh,
It's like-
yeah, it is.
It's the same thing.
Okay, then what you got?
Well, mine is an equal to an minus 1 plus n, and he just has it, an plus 1 is equal to an plus n.
Beautiful. That's it. That's it. Is this what you had 2K, something like this, or? And so then Alex had this plus n minus 1. Was that it?
I got an plus 1 equals an plus n.
Okay, let's check these two out, because they're a little bit different. So let's just check them out. That one, I feel like they're really the right idea. So that's the great part. So kudos to you for getting it. So let's check this one out. So this is going to be, first we have to initialize, right? So we're going to let A1 be 1 in both of them. So here we're going to let A sub 1 equal 1. Both of these are recursive, and that's, I don't know how to do this without recursive, so, well, maybe I do, but wait, okay, it's pretty fancy. So A sub 1 equals 1, so that would mean that A sub 2, so here now, see this, we got a little bit of a weird rhythm problem here. So to get the second term, A sub 2 equals A sub 1, but what's this n gonna be? 2. So that's gonna take me up to 3 on that one. So that's 1 plus 2 is 3. Do you see that?
Yeah, I do see that.
Okay, so so that's really close, but a little bit off. But let's try this one here. So then A sub 2, so here, so now n equals 1. I think this one might get it for us, because to get A sub 2 out of this, what does n have to be? 1. So if n equals 1, then we've got this equals A sub 1 plus 1. And that's going to get me the 2. So now it's 1 plus 1 equals 2. So you had the right idea, Alex. It was just a little bit off on the rhythm. But yeah, beautiful. Like, awesome seeing that it was the previous term plus a changing thing, right? And what did you come up with?
I think I overcomplicated it, but it works.
What? Ooh, I like that. Oh, do tell.
I think A sub n plus 2
Oh shit.
equals A open parentheses A sub n plus 1 minus A sub n close parentheses. Sorry, like parentheses around the two, the addition.
Okay, so hold on.
Sorry. So.
You want to write it for me?
Yeah.
I think it just sounds so much easier than explaining your notation, please. Thank you. Yeah.
So is this still extra credit for next class if we're gonna have?
Was this the extra credit?
I believe
Oh,
so.
oh shit. Yeah, no, not anymore. I'll come up with a new extra credit. Is this what I said was extra credit?
You did.
Boy,
You did.
I sure do forget stuff fast, don't I? Wow.
We could put the recording too.
Got it recorded
Oh, no.
evidence.
No, I believe it. I'll come up with some new extra credits.
I think I overcomplicated.
Thank you.
I will give some extra credits though. For folks wanting extra credit, I'll come up with something. Oh, wow. Okay, so we can simplify this then. So there's two of these. It's 2an plus 1 minus a sub n. Do you see what I'm doing there, kids? That plus that minus a sub n plus 1. Wowza. So we need two initializers. Ooh, this is really interesting. So let's see. So we need to know a1 and a2. So a sub 2 would be 2. And then using your formula, if we let n equal 1, then this is a sub 3 equals 2 times a sub 2 minus, this should be minus, that is plus 1, okay. I was looking at the plus 1 on the index, so minus a1 plus 1. How did you come up with this? This is quite.
It gets the difference between the previous two and adds them to the n minus 1 plus the current value.
Oh wow, that's beautiful. So let's see. So when a1 equals 1, so that'll be 1. So and then this is 2. So it's 2 times 2 minus 1 plus 1 equals 4. Holy shit. And then a sub 4 is going to be 2 times a sub 3 minus a sub 2 plus 1. So that's 2 times 4 minus 2 plus 1. So that is 5. I think that's 5, right? Wait, no, it's 8. No. 8 minus 2 is 7. It's 7. Holy smokes.
Magic.
Pretty cool. I just gotta check one more. So this is so exciting. So this is a sub 4 minus a sub 3 plus 1. Holy shit. So that is 2 of those. So 14 minus 4 plus 1. So 11. Dude. Oh, yeah, you don't know. You don't know. You're just like creating incredibly complicated formulas that work. Beautiful. Wow. That's beautiful. That seems to work. That's fucking awesome. I gotta write this down because there's a way to solve these, and I want to do it over the weekend. There's another way, a thing called a Z-transform that allows you to actually convert the. Oh my god, this is exciting. Okay, so there. Okay, cool. It's not like go on the road together and make $1 million, retire exciting. But it's pretty awesome. Holy smokes, okay. God, I don't know if there's anything left to do now. Yeah.
Exhale.
Can you go over the, if there's...
Yeah, what you got?
I don't know, I was looking over the web work, and I don't understand, like, the pyramid.
Let's talk. Oh, cool. That's a great idea. So let's take a look at an
We're not gonna
example.
meet on Monday.
Yeah. Well, why not? Yes.
I don't get it.
Oh, okay.
Like,
So I was checking out the homework,
Yeah, that's for sure.
and one of the problems, well, here, let me actually do it let me do a slightly different one to show you what we need to do. Because I don't want to take the fun away.
Yeah.
If I show you, there's no fun. So there's a pyramid, and there might be more than one of these, but what problem is that?
15
15.
and 14.
15. Yeah, there are 2 of them, right? Okay. So these pyramid problems are multiple sequences together. There's a lot of stuff going on. The sequences are the rows. How do you move from one row to the next? And you have to catch the pattern. So like imagine you were trying to write a piece of code to generate that pyramid. That's basically it. So you've got something like this. What's the next row here?
U1.
What's that, Joey?
1 first on the side.
So 1, okay, awesome. So Joey's catching the rhythm here that there's always 1s on the outside. I like that. So that's definitely part of the thinking.
And then it would be 5.
How you getting that?
1 plus 4.
Beautiful.
And then it would be 10.
Nice.
And then it would be 10 again.
Yeah.
And then it would be 5 again. And then 1.
Awesome. Yeah. Has anybody seen this before?
Yeah.
This is called Pascal's triangle. And you probably saw it in calc because I use it to like talk about multiplying out multinomials. But this is Pascal's triangle. And so Yvonne, that's kind of the game here. But I'm not gonna, just think about it. You've got quite a bit of time, and we'll touch base on it. But each one of those two problems has kind of a different rhythm going on.
Yeah.
But it'll be fun. It'll be fun. When you guys get home from the clubs, you're tired.
I don't know what's going on here though.
Let me see that
It's
one.
3, 0, and then
Let me see.
there's a -3 in there.
And then the 6.
Oh man. Like that makes perfect sense, but that one does not.
Yeah, looks challenging.
Oh man.
Glad I don't have to. You'll be okay if we don't talk about it till Wednesday. But
Okay.
if you get it, you're gonna feel so
you
good.
Say it, you say it.
I already did it, doesn't help.
What did you do? What did you say? Do what?
Use
So
the
you're
hint.
looking at subtracting.
It gives
you a little hint.
to
It
get
just
the
says
next term in each row.
To subtract things, but like,
Yeah.
Yeah, so 3 minus.
Oh,
Second, second, fourth.
geez, I'm sorry you can't get it in less than 2 minutes of thinking about it, buddy. No, I'm not telling you.
tragic.
3 minus 0 is 3.
Alrighty, my friends.
Yeah, but it's not the first one.
Yeah, I know.
3 minus 1.
Does anybody see Abraham, like, outside of class?
I saw him yesterday.
I have him in the program tomorrow.
You'll see him in programming. Would you let him know, I mean, I'll send out an email just to remind him, but let him know this is web work, and let him know that we're definitely meeting on Monday.
And Halloween half day, right?
Yeah, just a half day. Alrighty, friends, thanks everybody.
There's no math on Wednesday.
Sad.
Alright,